Welcome back. I'm now going to show you quickly how to calculate tolerance using OR. This could also be done in Excel, but it's probably easier seeing as you have the data set available in OR to work in OR. Now, first of all, what is tolerance? Well, tolerance is basically how much biomass loss is there per unit of infection. So it's an indication if a plant can continue to grow healthily in the presence of infection or not. So how sensitive is it to being infected with these rust pustules? So we can first of all calculate tolerance in our data set. We do that first by looking at the loss in biomass. So that's the difference between the control plants, so the non-inoculated plants. So that was biomass not inoculated minus, and I'm using the dollar symbol to pull out the columns here. We want a biomass inoculated. So the difference between the healthy control plants and the diseased infected plants. So if we look at that difference, then we'll know how much loss there was as a result of this infection. And here we see the values. Now I want to capture those values, so I define something called loss. I use the backward arrow here, so that's the less than and the dash next to each other. So I subtract this from this, and then I assign it to something called loss. And let's have a look at those numbers. Okay, so here we see in general that there's a loss of between 5 and 10 grams, shall we say, in the biomass. But there are some instances where there are negative numbers here. So this suggests that in fact the plants here gained in biomass as a result of the infection. And that's not really expected at all. We don't expect plants to become healthier and bigger and stronger as a result of a pathogen growing on them. Now, there could be explanations for why these data points exist, but for our definition of loss, it doesn't make sense to be talking about negative numbers. So probably the simplest thing to do, and you'll probably have thought of it already yourself, what to do with these negative numbers, we will just make them zero. So we'll say that there is no loss in these plants, which technically is true. There is no loss. In fact, there's a gain, but we don't necessarily need to specify that gain. So we'll say, if we take our object, our vector loss, we use the square brackets, and after this, inside the square brackets here, we'll just pull out the values that are negative. So we're doing a test on the vector itself, testing to see whether there are negative values there. In some cases there are true, so there are negative values. So what this will do is it'll pull out all the ones where this is true. So we'll just subset out the ones that have true here, so they're the negative numbers, and we can overwrite those. We can delete them and overwrite them, find and replace essentially with the number 0. So now if I plot loss again, so I go up here and press Control Enter again, we'll see that those negative numbers have now disappeared. And you can toggle between plots here, one of the nice things in RStudio. So you'll see here negative numbers, now they're all 0. That's great. But so we have defined loss, we've gotten rid of negative losses. Now we have to think about the percentage reduction. So the percentage reduction is this amount of loss divided by the control biomass, so the biomass of not inoculated plants. So we'll say percent reduction, maybe, give it your own name. And we will, again, because we're dealing with percentages, 100 times this loss, and that's divided by, data, and it's biomass not inoculated. Okay, and let's plot this, just have a look. You see again what's going on here. Okay, so we've percentages reduction ranging from 0 up to 20-25% reduction. Okay, that's the first thing, but the tolerance now is the percentage reduction divided by the percentage of infection. So it's the biomass loss per unit infection, and because we've got percentages above and below the line, it's a dimensionless quantity, this tolerance. So we'll call tolerance is our percentage reduction divided by our infection. There you go. And now let's plot tolerance. Yes. Now you'll see in most of the cases the tolerance is close to being 0. There are some values which are above 0, but in general it's not looking very good here. There's an awful lot of values very close to 0, so the distribution of these values is not exactly as we would like. Now it doesn't necessarily have to be normally distributed, but you can imagine after fitting a linear model, the residuals should be normally distributed, and there's already an indication here that it'll be quite difficult to have a simple linear model which gives us a normal set of residuals after that fit. Anyway, we can see that by running a linear model, but first we would like to add tolerance to our data set. So we have data, and we use the cbind function, which is for column bind. We can also use or bind if we wanted to add something, another row, but here we want to add a new column, and so we're cbinding, column binding our original data with this new tolerance vector, and we just overwrite data then with this new combination of data with the new column tolerance. So let's have it just to make sure. Let's look at the head of that new data set called data, and now you'll see tolerance has been added on in the correct order just onto the old data set. So now we can run analysis of variance again. So for instance, you might want to recycle the code you had above, just go up there, copy it, and now let's call it AOV2. Our response variable is not infection, but tolerance. And you'll see it, it runs well. We can get a summary of that. And you can check the ANOVA table and see whether there is significant interaction here or not, and whether there are significant cultivar or soil effects. I'll leave that up to you. Now, one little trick that I didn't show you last time, if we want to plot the output of the analysis of variance function, we can first specify that we don't want a single plot in this window over here, but we want 2 rows and 2 columns. Use the par mfrow command here, and I'm saying 2 rows and 2 columns, so I'll do that first. And now if I hit plot AOV2, we'll see that the 4 plots come up at once next to each other, so that's quite nice. If we look at the residuals here, things are not looking very good in terms of constant variance, so we don't have constant variance, and we also probably don't have linearity. Now, I'm not going to ask you to go in and start doing transformations of the tolerance data. You can play around with that if you want to deal with this issue of non-normality, to see can you get that back a little bit more on the expected line. But that, I think, goes beyond the scope of today's practical. In this tutorial or this little video, I just wanted to show you how to get add your tolerance column. You can of course do these steps in Excel if you want as well, and re-import the data into R. Okay, hope that's been helpful.